Hi students, in this session we are discussing the topic other models. Up to now in the previous sessions we are discussed few models. So uh, here the other model defined based on the production possibility set. So for this production possibility set, it is based on this is giving the other model in this topic, and it is based on the scale which is returning the constant units compared, means the hypothesis giving what are the constant returns to scale. So when the scale is showing high, it means it's the highest rated component. So whenever the highest a scale is showing highest rated component, then that is obviously the efficient one. So in the previous session, the model shown in 15.9, you can see this model here in the fifth uh, fifth page. This is the model uh, showing. This model is based on the hypothesis that the units being compared operate with constant returns to scale. So whenever we reach the constant returns to scale, then it is the efficient one, obviously. Okay. So in this model, the hypothesis is based on the uh, units being compared operate with constant returns to scale. And whenever we are expressing our scale, how we are expressing our scale? By means of returns. How we are taking these returns? By showing some variations. Where we are showing variations? The variations within the quantity of outputs in terms of variations in the quantity of inputs used. So when the returns to scale are constant, if the inputs constant means if the inputs increase in a given proportion, then the outputs also increase in the same proportion. Then the hypothesis of constant returns to scale leads to an efficient frontier, means that is the efficient one, like the one shown in 15.1 model. What is the 15.1 model showing? You can see it in the first page. Wait a minute, we are going I'll show in the first page the 15.1 model. Here it is, we already discussed this one. So with this model, we are achieving the efficiency within the decision making unit DMU. Okay, so to get that efficient frontier scale returns, we have to make them constant. How we will model this hypothesis in this session, in this topic. So for that, if we are taking the x variable denotes the matrix of inputs used by the n units, and y denotes the corresponding matrix of units of outputs, then the hypothesis of constant returns to scale we can express as the production possibility set. The production possibility set is defined as P is equal to xy such that x is greater than x lambda and y is less than or equal to y lambda, where the lambda is greater than or equal to 0. The set is saying this. Here it means the xy belongs to P, and any other point by means how we are getting other points by multiplying with a constant lambda or lambda value. Okay, then any other point of the form kx or ky by multiplying x and y are already belongs to P, and we are associating some weights or some multiplying applying products by taking any constant. Here the k is greater than 0 is a constant value, any other value. Then it is also the product is also belongs to the production possibility set. This production possibility set is representing here with the P, denoting with the P. Okay, so this is the new model suggested in other models. And here, if the hypothesis of constant returns to scale is not adequate, we have to resort to formulations other than 5.9 suggested models. For that, for example, if we are taking Banker-Charnas-Cooper model, which is based on the hypothesis of variables returns to scale and takes this form. This is already we discussed in the previous sessions. So, it is the uh, dual means here it is minimizing the objective function subject to objective function. Okay, so for that we are achieving this scale. In this diagram, the scale is continuously increasing and achieving the efficiency efficiency, and all these are the units giving efficient units within the scale. So in this model, the production possibility set is defined for the above model is P is equal to xy such that x is greater than or equal to x lambda and y is less than or equal to y lambda, where here we are up producting the lambda with another variable e, where E lambda is equal to 1 and lambda is greater than or equal to 0. Here the E is a unit vector. The C is a unit vector. So the only difference between the previous model and the CCR model is from the condition this one, which together with the constraints in the above formula, which is 15.32, specifies that the efficient frontier is convex one. So the model describes above do not exhaust the broad variety of formulations that have been proposed in the framework of data envelopment analysis, but although they represent good examples, these are the examples, other models. Okay, then to the end of this session, the CCR model was first proposed by Charnes in 1978, and after that, uh, an extensive discussion of data envelopment analysis model, the reader is referred to Cooper in 2000, and after that more recent developments are described in Ray. So in this way the model is CCR model. And in the above discussion for the above discussion, a description of production functions and returns to scale can be found in any microeconomics textbooks. These are the references for reading for the above topic to form the other models using these hypotheses. This is the reference. Microeconomics textbooks will give you the description of production functions and returns to scale. Okay, students, this topic is completed. Hope you are all reading well and preparing well for the exams. Thank you.